Okay, hello. Hello.
Hi, madam.
Okay.
Hello, madam.
So please, we are starting. But before we start today's lesson, I just want us to revise what we did last week. So last week we started with the limits of a function, and we looked at how to find the limits of polynomial functions. Okay, we saw that if we want to find the limits of a polynomial function, we just substitute the value of a into the function. And then we also looked at how to find the limits of a rational function. And we said that to find the limit of a rational function, we have to look for the domain of the function. Now, if the a given is in the domain, then we just substitute the a into the function. But if it is not in the domain, we have to simplify. So this is an example where to find the limits as s approaches 4 of x squared minus 16 over x minus 4. We saw that 4 is not in the domain. So in this case, we have to simplify before solving it. Then we also looked at some loss of limits. We looked at loss of limits. And then we also looked at limits of trig functions. Okay. And with that, we started with the theory that the limit as s approaches 0 of sine x over s is equal to 1. And we said that the x is the angle. So that means that the value of the angle should be the same as the value dividing the denominator. Okay, so the limit as s approaches 0 of sine an angle divided by the value of the angle will give us 0. So we looked at this example and we were able to prove that the limit as s approaches 0 of tan x over s is 1. So we solved some example. Then from there, we looked at the one-sided limits. So we said that the one-sided limit, it means that we are approaching the limit either from the left or from the right. Okay. Then we looked at the relationship between the one-sided limit and the two-sided limit. And we said that if approaching a limit from the left is the same as approaching the limit from the right, the value that are the same, then the limit at that value will be the same as that. So we looked at some example using the absolute function. Then from there, we also looked at the squeeze theory. We said that if you have three functions, f, g, and h, and g lies between f and h. If the limit as s approaches a of f of x is L, and the limit as s approaches a of h of s is also L, then the limit of g of s is also L. That is the squeeze theory. Then from there, we looked at continuity. We said that the behavior of a graph, which is continuous, has no break. Okay. So we looked at some examples of these continuous functions. Okay. Then from there, we looked at the definition of a continuous function. And we said that if you have a function f, we say that the function f is continuous at a, if f of a exists 1, 2, if the limit as s approaches a of f of s also exists, and the limit as s approaches a of f of s is equal to f of a, then it means that the function is continuous. But if that function does not obey any of these three conditions, or then it means that that function is not continuous. So we looked at some examples. Then from there, we also moved on to derivative. Hey, you're making noise. Derivatives of a function. And then the derivative, we looked at the definition of the derivative of a function, that is f prime, or what we call the first principle. And then we said that by the first principle, f prime of x, which is the same as the slope of the function, is equal to the limit as h approaches 0 of f of s plus h minus f of s, all divided by h. That is the first principle. And we solved about 2 examples. We also have some Yeah, self-assessment questions at the back. And that was what we did last week. So this week we want to start with lesson 4. Lesson 4. But any question on the lesson 3 before we move on to lesson 4? Am I online?
Yes, madam.
Yes,
Yes,
madam.
madam. Yes.
Yes, please.
Any question on the lesson 3?
You can continue.
Are you sure I can continue? Because I learned someone saying that I just came to read the notes. So if there is something you don't understand, but to me, I saw that I didn't read the notes. And those who
Oh,
understand,
madam, it was not towards you. I think that it was towards a colleague. Madam, no, it was not towards you. Madam,
okay,
you have explained everything clearly. So it was not towards you. Thank you, madam.
I think I'm saying that madam, the lady, okay, I'm not the
No,
lady.
the only thing he said is you were speeding.
What's on your platform? The platform.
Okay, then I wasn't there. But now let's continue. Let's go.
Okay, so today we are continuing with the derivative, which is the same as the differentiation. So we now know the first principle, which is f prime of s is equal to f of s plus h minus f of s divided by h. So they want to look at other ways of finding the derivative of a function. So at the end of the course, the student should be able to demonstrate knowledge in rules for differentiation. So please, you should be able to demonstrate knowledge in rules for differentiation. And then higher order derivative, tangent and normal, how to find local extrema, how to find increasing and decreasing function, and then also using the first derivative tests. Let's continue. So it's the same thing. So we want to look at rules, and the first rule we want to look at is the derivative of a constant function. So a constant, anytime you differentiate a constant, if you have a c, which is a constant, anytime you differentiate a constant, you will get 0. So if f of s is equal to c, where c is a constant, then f prime of x is equal to 0. So example, find f prime if f of x is equal to 200 pi. This is pi. 200 pi is a constant. So when I differentiate 200 pi, I will get 0. So that is the first rule, derivative of a constant. Then the next rule, we want to look at derivative, the power rule. The power rule. It says that if f of s is equal to s to the power n, where n is any real number, then f prime of x is equal to n x to the power n minus 1. Okay, so let's continue. So we just saw that anytime I differentiate a constant, anytime I differentiate a constant, f of s is equal to a constant c, then f prime of c of x give me 0. This is 1. And then 2 is the power rule. It says that if f of x is equal to x to the power n, then when I differentiate this function, it is given by, so you drop the n, it is n x to the power n minus 1. So this is the derivative of, so this is called the power rule. And this one is the derivative of a constant. So what do you get when you differentiate 10,000?
0.
0.
Madam, 0.
Okay. Let's continue. So that is it. So by the power rule, if I have f of x is equal to s to the power 5, then my f prime will be equal to, I will drop my 5, so I have 5. and then x, then 5 minus 1, which is 4. This is called the power rule. This is the power rule. Then I will have the third one. Okay, so we have another example. We have f of x is equal to x to the power. Okay, so I have f of x. Okay, so we are still on the power rule. We have f of x is equal to square root of x. Okay, so I hope you all know that square root of x is the same as x to the power 1 over 2. So to differentiate this by the power rule, this is 1 over 2, x to the power 1 over 2 minus 1, which is the same as 1 over 2, x to the power minus half. Okay, and by indices, this minus half is the same as 1 over 2 x. So this is the same as this. I hope you understand this.
Yes,
Yes.
please.
Yes.
So let's continue. So I'll give you another example, then you will differentiate it for me. Okay, so if f of x is equal to 1 over the cube root of x, find f prime of x. Okay, so if f of x is equal to 1 over cube root of x, find f of x. So how do you go about this? Maybe Richard will answer this. Richard. Rich, please answer that for us. We have f of x is equal to 1 over cube root of x. I want you to find f of x for us. Hey, the females there, you are not raising your hands. Okay, so I want one lady. So Richard or a lady will answer. Richard, what will you get? How do you go about it? Let's start.
Okay, the power cube root 3.
So I'll write f of x is equal to
X to the power 1 over 3.
There's one up there. It's 1 over cube root of x.
Oh, okay. So yeah, so 1 over into
1
brackets
over
x into brackets x to the power 1 over 3.
1 over 3. Okay.
Then the next step is
Okay.
1 over 3.
Hey, please, there's one up there.
Yes, that's what I'm saying. So 1 over
1 over
3 exponent 1 over 3 will multiply the x.
Okay, so let me write what you want to do. Okay, so it will be, you said it. Okay, please try.
X to the power negative 1 over 3.
Okay,
Oh yeah.
so the 1 over x to the power 1 over 3 is the same as x to the power negative 1 over 3.
Negative 1 over 3.
Okay, so let's continue. What do I write?
1 over 3.
So f prime of x is equal to,
You drop the minus 1 over 3.
I have 1 over negative 1 over 3.
1 over 3.
X
Next,
to the power negative 1 over 3 minus 1.
negative 1 over 3 minus 1. Okay, so that would be what?
Negative 1 over 3.
Negative 1 over 3.
Exponent 4 over negative 4 over 3.
Negative 4 over 3. Okay. So that's what I'll get. All 1 over negative 1 over 3 cube roots s to the power 4. Is it the same?
Yes.
Yes, yes, madam.
Okay, thank you very much. Okay, so it's 1 over 4, 1 over 3, s to the power minus 4 over 3. Okay, so that's on the. Then we have what we call sum rule. Sum rule, it says that if f and g are differentiable function at x, then differentiating the sum of the two together is the same as differentiating f plus differentiating g. So you differentiate f plus you differentiate g if it's the difference, and you differentiate f minus, so you differentiate f minus, you differentiate g. So example, we want to find f prime if f of x is equal to s to the power 7, s to the power 7 plus square root of x. Okay, so I have the function f of x is equal to s to the power 7 plus square root of x. Okay, so by the sum rule, f prime of x will be equal to, I will differentiate this one, so d dx. So the differential, I can write it at d dx of x to the power 7 plus d dx. So the differential is the same as d, then d over dx of the function. That is if I'm differentiating with respect to x times root x. So when I differentiate s to the power 7, be capable. If I differentiate s to the power 7 by the sum rule, it's going to be, so when I power rule, this is 7, good afternoon, 7e to the power 6 plus, then I'll differentiate this. This is 1 over 2 x to the power negative half, which is the same as 7 s to the power 6 plus 1 over 2 root x. Mr. Nkum, Afishapa. Please, is it okay?
No, it's not okay. How you differentiated the square root of x? We are a little bit confused there.
Hey, uncle, I just differentiated square root of x.
Yes,
It's down here. It's down here.
yes,
Square root of x is the same as s to the power half. And to differentiate this, I'll drop the half. Then I'll have s to the power 1 over 2 minus 1, which is 1 over 2 s to the power minus half. And by indices, this is the same as 1 over 2 s to the power half. And s to the power half is the same as square root of x. We just did this one, Michael. It's even here. Is it okay now?
It's clear now. Let's proceed.
Okay. So thank you. So that's the sum rule. You differentiate the first one, then you differentiate the second one, plus the differential of the second one. Okay. Clean my board. Okay, so let's see. Okay. So we have 7 s to the power 6 plus 1 over 2 s to the power negative 1 over 2, which is the same as 1 over 2 root x. It says that if f is differentiable at x, then for any constant. So also, if I have a constant times the function, it's the same as bringing the constant out and then differentiating the function. So example, if I have f of x, sorry, Okay. If I have f of s is equal to maybe 6 s to the power 7, to differentiate this, f prime of x is the same as, I'll bring the x out. Okay, so the first step is I'll write d dx of 6s to the power 7. And this is the constant. So by that remark, it means that I can bring the 6 out. Then I'll have d dx of x to the power 7. So this is 6, still 6 out. Then I will differentiate this. Then differential of this is 7. Then s to the power 7 minus 1, which is 6. So you can multiply 6 by 7. And s to the power. So 42 x to the power 6. So that's what you're going to get. So that's the meaning of this constants. Okay. So for example, find f prime for the following function. So I have f of s is equal to 4x to the power 5. So that will be, I will have d ds of 4x to the power 5. I'll bring the x out, then I have d ds of x to the power 5, which is the same as, then I have the 4. Differential of x to the power 5 is 5x to the power 4. So 4 times 5 is 20. So I have 20 x to the power 5. Then the second one, I have 3 times square root of s plus 5 times s squared. Okay. So to differentiate this one, I'm going to apply so many laws. So I have d dx of 3 root of s plus 5 s squared. This one, I'll first apply the sum rule. So sum rule says that I should differentiate the first one, the first term, plus the differential of the second term. Yes, Steve, no two.
Yeah, madam. Yes, the speed is too much. Please, kindly take your time for us. Thank you.
Okay, thank you. Okay, so as I was saying, we are using the sum rule. Okay, so when I differentiate this one, it is differential of the first term plus the differential of the second term. So d ds of 3x to the power, so 3 s square root of x is the same as s to the power 1 over 2. So I have 3 times s to the power 1 over 2 plus d dx of 5s squared. Then I'll apply that remark, which says that a constant times a differentiable function. I'll bring the constant out, then I'll differentiate the function. So I have the 3, then differential of x to the power 1 over 2 is 1 over 2 x to the power minus half, which is 1 minus half is minus half, plus, then I differentiate this. I bring the constant out, then I want to differentiate s squared. Differential of s squared is 2 times x to the power 2 minus 1, which is 1. So that's what I have. So this 3 times half is the same as 3 over 2. Then I have s to the power minus 1 over 2 plus, then 5 times 2 is 10. I have the 10x. Are you okay?
Yes, madam.
Yes, madam.
Yes.
Then we have the power rule, product rule. Product rule. It says that if f, okay, so that's supposed to be f and g. So if I have two differentiable functions at x, then the differential of the product of the two is giving us. So to differentiate two differentiable functions by the product rule.
Hello, madam.
Hello.
Yes, good afternoon.
Yeah, good afternoon.
Yes, please. You've claimed it. I wanted to make a suggestion. When I'm doing it, I don't go through the steps like how the sum rule.
You
The
don't have
sum
to
will
go
have.
through it, but I'm teaching. That's why I have to take my time and go through.
Oh,
So
okay.
let's see how you do it. I have f of x. F of x is equal to x to the power 7 plus square root of x. How do you go about it?
Yes. So
So f prime of x is
ddx. Yes, ddx of, and then I'll differentiate this one and this all together. So I'll get 7x exponent 6 plus
so you will not bring the
half
ddx. You will
x.
not bring the ddx.
No, I'll
So you
bring
just
it
write f
first.
prime is equal to
No, I'll bring it
7x to the
first.
power 6 plus. You bring the
I'll bring it
ddx.
first. Yes, I'll bring it first.
ddx.
Of this.
Then I'll open a bracket.
Equal to.
Yes,
No.
please. Yes. Of all.
Of x to the power 7
Plus.
okay.
And then I'll
Like
differentiate
this.
it. Yes, please.
So
And then I'll
7x
get
to the
7x
power 6
exponent 6
plus 1 over.
plus half. Okay, yes. Yes.
Like this, right?
Yes, please.
It's okay. That is it.
Okay.
It's okay. If you know how to do it, you can just, because even when you see this one, when you see this and you want to find f prime, you can just, if it's section A, it is f prime of x is equal to 7x to the power 6 plus 1 over 2 root x. You know this. That's okay. I think there's a hand up.
Thank
Yeah,
you.
Eric. So I have to take my time and go through the process because I know some of you have forgotten about all these things. Okay, Eric, your hand is up.
Yes, please. The
Eric.
F prime, F prime. Yes, I think that indicates a first derivative. So I don't know why you are always bringing the D.
Differential.
Yes. So when you indicate it this way, do we need to also bring the D, the X?
If you indicate it this way, it means that you are differentiating. So you can even, instead of writing this, if you want to use d dx, you can just write d dx of f of x is equal to d dx of x to the power 7 plus root x. So you are differentiating both sides.
Okay.
And d dx is the same as f prime, which is equal to the differential of this is to the power 6 plus 1 over 2 root x. Is that okay?
Yes, please. Okay.
So d dx means that you're differentiating. If I write f prime, it means I'm differentiating.
The first derivative. Okay. Thank you, Doc.
Okay, so I can also decide to write it like this. So f prime of x is equal to x to the power 7 plus root x prime. This one also means that I'm differentiating. Is that okay? Let's continue. So we are on product rule. Product rule says that if I want to find the derivative of two differentiable functions, f of x and h of g of x, both of them are differentiable at x. To differentiate product of two functions, that's how we go about it. So please, I'm bringing the equal sign down. What you do is you keep one, the first one, so you keep f of x, then you differentiate the second one, plus you keep the first one, then you differentiate the second one. You can decide to keep the first one first. We know that addition is commutative, so you can keep the first one first, second one first, and differentiate the first one, plus you keep the first one and differentiate. So it's the same thing. So example, if I have the function f of x is equal to maybe x to the power 7 times root x, you know that x to the power 7 is differentiable and root x is also differentiable. So to differentiate this, by the product rule, my f prime of x will be equal to, so I'll keep this x to the power 7, then I will differentiate with x plus, I will keep with x, then I will differentiate x to the power 7. Okay, so you know that this is x to the power 7. Root x, I know it is 1 over, so 1 will multiply this over 2 root x. Then plus this one, I have root x times the differential of this is 7 x to the power 6. So this is the same as x to the power 7 over 2 root x plus 7 x to the power 6 root x is the same thing. So that's what you're supposed to get. So let's look at the examples that I have here. Okay, so this example, if I have the first differentiable function and second differentiable function, and I want to differentiate by the product rule, I have to keep the first differentiable function. So I'll keep x squared plus x minus 1. Then I will differentiate the second one, 2x plus 4. When I differentiate 2x, I will get 2. When I differentiate 4, I'll get 0. So this whole function, when I differentiate, I'll get 2 plus, I'll keep the 2x plus 4. So I keep the 2x plus 4. Then I will differentiate x squared plus x minus 1. That's one. I'm combining a lot of things. So for this differential of this, we are even combining sum rule and power rule. So when I differentiate 2x, x squared, I'll get 2x. When I differentiate x, I'll get 1. When I differentiate negative 1, I'll get 0. So this will give me 2x plus 1. Then you can expand and simplify. Yeah, Christian.
Okay, madam, can you go back to that question we just solved, please? Can you please go back? Yes. So what I'm suggesting is that can we first expand this bracket, open the bracket, and first multiply before we differentiate?
Yeah. Okay, so you can expand this. Yeah, you can expand it and then use the sum rule. That's allowed. But we just want to treat quotient product rule. So that's the reason why I'm leaving it like this. So it's not only one method. You can use the product rule, or you expand and use the sum rule. But the most important thing is the understanding. But here I want to treat product rule. That's why I'm using the product rule here. Okay. So if you are using product rule, then you cannot expand it. But that's when you can decide to use product rule or any rule, but you're going to get the same answer. But here I'm treating product rule. So since I'm treating product rule, I don't have to open the brackets. Are you okay?
Because it's becoming manya in my eyes. Okay, thank you.
So if it's a normal question, you can expand and solve. But since we are treating products, we have to apply the product rule by letting this one be f of x and this one be g of x. Then I'll continue.
Madam, can't you be restricted to use the product rule in the question? Can't you be restricted?
No, you will not be restricted, but there are some questions that you can. The only method that you can use is product rule.
Oh, okay. Thank you.
Okay. Well,
Madam, this particular rule, you come again with, you go with it once again.
And Madam President, can we take a simple question, and then use that one on now before we go back to what is in the slides? Because this one,
no, You know,
No, even if
even
Madam goes to this one, the right who understand.
someone elective math, my
She
best
just
yes, sir.
she should just solve this. It will be okay.
One elective math, my bet na hana my best step.
Oh, madam, we did elective mathematics, but right now,
And
since we have two or four cases, the children have,
Madam,
their pressure they are giving us as, erase all the things that we learned in our exercise.
You did true and poor.
hello, madam.
So I have f of x, yes, is equal to x squared plus x minus 1 times 2x plus 4. Yeah, please, someone called.
Madam, so him asking of a simple question to review his
I cannot
RPK.
hear
I'm
you.
suggesting you. Hello, madam. Hello, madam.
Yes, dear.
So, madam,
Yeah,
I
I'm here.
was suggesting that we use a simple question like probably x squared be multiplied by 2x plus 1.
I'm saying let's just go by this. It will be okay.
I did one. I did x to the power 7
Okay.
times s
So,
root of
madam,
x.
yes, I
I solved a
understand.
simple one before
I'm
coming
just
here.
suggesting that
Maybe you
please,
did.
so that those who might have forgotten the procedure, no, this thing will just make them.
I started with a very simple question that if
Okay.
f of x is equal to x to the power 7 root x, I solved this example.
Okay.
Simple example. before
Yes,
coming
yes,
here.
yes.
Then I said this would be f. This would
I don't have any problem with the new one. Only that I was suggesting.
new one, Ben. This
We all
question.
cope. We are all coping. We all cope.
Coping, Ben. When we want your elective maths, you've heard that you're going to do elective maths. Instead of you to look for someone to teach you, I've given you have the course outline. Instead of you to go and read the SS and you don't want to do maths before.
Problem book.
You didn't even
But
go.
then you get a problem book now.
There's a handout.
Yeah,
Please,
problem
the
book.
handout is please. You can talk.
Long time ago in Bethlehem.
Hello, madam.
There is a handout. Yes.
Madam, so I was suggesting that probably.
Yes, madam.
Hello, madam. Madam.
Can I talk?
And so let's listen to the one who suggested.
I was
suggesting that
even, madam, you can still use the product rule, or probably we just expand, we just multiply the two expressions, then we find the derivative of it. Any of them will give us the final answer.
But here I'm treating product rule.
I understand.
So I don't
but
want to expand.
I wanted them to know that if you use the product rule or the other rule, it will.
If you expand and simplify,
you get the same answer.
If you expand and simplify, you're going to get the same answer.
You get the same. But
if you are treating product rule and you expand, but if you are treating product rule, and you expand and simplify, waiting. So please here, I'm treating product rule. There were some of the functions you cannot expand them. Okay.
We are even going to teach students, so we need to understand all the necessary procedures. So let's go by what you are dealing with. If it is finals, we can go by any other means.
Thank you. So we are not going by any other means. We are going by product rule. So
I mean, finals, if it is sentence, we go by any means.
If you expand, if it's just a general question, you can expand and you differentiate. It's fine. But if it's under a particular topic like product rule, then you have to use product rule. Okay, so I'll treat this as my f of x. Then I'll treat this as my g of x. Okay.
Okay.
So the formula says that Okay, so I'll call this one f of x times g of x. So d dx of f of x g of x by the product rule is I'll keep f of x. Then I will differentiate g of x plus I'll keep g of x. Then I will differentiate f of x.
Yes.
So let's continue. Please, I'm bringing the equal to sign here. So my f of x is x to the power 2 plus x minus 1. So I'll keep that one. Then I will differentiate 2x plus x. So d dx of 2x plus 4. Then plus the next one, I will keep 2x plus 4. Then I will differentiate my f of x, which is x squared plus x minus 1. Okay, so let's continue. This is x squared plus x minus 1. Then differential of 2x plus 1. By what we learned, we know that some rule I can differentiate 2x, then I'll differentiate 4. When I differentiate 2x, I was told that I can bring the constant out, then I'll differentiate x. When I differentiate x, I'm going to get 1. I'm going to get 1 times x to the power 1 minus 1, which is, so 1 times x to the power 1 minus 1. So that's the differential of this. Then when I differentiate a constant, I'll get 0. So I'll keep that. Then plus, I come here, this is 2x plus 4. Then I will differentiate this. Differential of 2x squared will give me 2x. Differential of x will give me 1. So this is x squared plus x minus 1. Then this, I have 2 times 1. X to the power 1 minus 1 is x to the power 0. Any number to the power 0 is 1. Then plus 2x plus 4. Then 2x plus 1. Please, the rest you can expand and simplify. But that's what you're supposed to get.
Thank you, madam.
Madam, please simplify for us. Some of us, you know.
It should simplify for you.
I should simplify. I find that
Simplify this one for you again. Hey.
Get your SHS as well, and also simplify very well. You multiply 2 by x squared and get 2x plus x minus 2 plus
Doc, you know,
4x.
you know, we have slow learners. I'm a slow learner. Thank you.
Okay, so please take your time and simplify this and this. This is x 6x squared. This plus this will give me, is it 12? Please, what do I get?
X. 12x.
2x plus
This is 12. Plus
and
2.
this and this will give me
2.
wait there. So that's what you get. Then the next one is the quotient rule. The quotient rule says that if I have two differentiable functions, f and g, x and g first is yes. Hello.
No. Please, another product rule. It seems we did only 2 examples. So I think that if we could have, engaged ourselves in about 4 or 5, we would have a broader understanding. Thank you.
If I will do what?
If you can kindly add 1 or 2 examples to the product rule so that at least you have the understanding well.
Thank you, please. We are ending next week. And you have some self-assessment questions. I'll give you the formula. Yes. I'll solve 1 or 2 questions. then you have to go and look for more questions. I even have self-assessment questions. And as I told you earlier, I said that this course is supposed to be a revision. Just refresh your mind on what you know already. So at the SHS level, you are supposed to
please,
use
madam, what you are learning is going to be what you are telling us, because it is not self-assessment something. Say, madam, it's not easy. The mathematics that we are doing this board, it is very difficult. So kindly have a time for us. Thank you.
Please, at least we should
it is not easy
respect
because
ourselves.
you have told yourself that
are going to
that
do
it is difficult.
So at least we should respect ourselves.
And then
please.
And two, the unfortunate thing is you have forgotten. You are not supposed to forget.
And the
what I'm treating right now, when I'm teaching the regular students, I don't think I will take my time to go through this to solve, because I will just give them the formula. Sometimes I will not even give them the formula. I will just tell them products and they will give me the formula. So
let's continue.
Hello.
Hello. And please, we are ending next week. So please, let's try and then finish something. Please.
Hello, madam.
Okay.
Doc.
Hello. Hello.
If I understand what my brother is saying, madam, you see, those on campus, because they came straight from either training college or SHS. So for them, they do remember.
Please, all this we are wasting our own time. Please, all this we are wasting our own time. Let's continue. Let Doc proceed. And we
please, I'm so sorry.
Please,
madam,
we are here to solve issues. We are here to solve issues. So you can't just say that we are just wasting our time and those stuff. If you don't understand anything,
that was waste of time and energy.
Please, it's fine. Please, it's okay. We are not wasting our time. It's okay. I'm not. You can. I will not call anyone. I'm not calling anyone. Please, we are not wasting our time. Let me continue, please. I'm the boss here, so please keep quiet. Let me continue, please. Let me continue. Okay.
Okay, madam. We here.
Please, the most important thing is for you to get the theory right. The theory says that if I want to differentiate two differentiable functions, I have f and g. The differential of two differentiable functions is given as f of x, then differential of g of x plus g of x times the differential of f of x. This is what you need. So anytime you see two functions, you call, so this one, you can see that you have two functions in brackets. So you call the first one your f of x, then the second one your g of x. So you go back to the formula and you just do your substitution. That is all. So to get this course right, you should get the concepts right, the theories, everything right, and everything will be fine. It's not about me solving so many questions, but it's about you getting the understanding and then also getting the theory. That is all. So we are on quotient rule. It says that if I have f and g, which are differentiable at x, and if g of x is not equal to 0, then the differential of the quotients, so I have f of x over g of x, it is given by this formula, g of x times the differential of f of x minus f of x times the differential of g of x, all divided by g of x. So please, I have a question here. I have f of x, or the function is x to the power 4 plus 2x minus 1, all divided by x to the power 3 times x to the power 2 plus. So here, the theory says that it will be the down question, that is the denominator, times the differential of the numerator minus the numerator times the differential of the denominator, all divided by the denominator square. Please, you take a look at this.
Madam, square of the denominator, right?
The square of the denominator.
Okay, okay.
So you come here. By that theory, it says that if I want to differentiate this one, it is the denominator first. So I write my denominator, 3x squared plus 5, times the differential of the numerator. So I have d dx of the numerator, minus my numerator. So I have the numerator, times the differential of the denominator, all divided by the denominator squared. So you come down, you have the denominator, then differential of the numerator. And you know that this numerator, you have to apply so many rules. I have to apply the power rule. The power rule says that if I have s to the power 4, it is 4, s to the power 4 minus 1, which is 3, plus I have a constant, so I keep the constant. Then I differentiate my x. When I differentiate x, I'll get 1. So I have 1 times, which is 2. Then I will differentiate the constant, 1 minus the constant. We know that when I differentiate a constant, I will get 0. You know that. So I am done with this part. Then minus, then I come to this place. I have x squared, x to the power 4 plus 2x minus 1. Then I come to the differential of the denominator. So this one, I have a constant. I'll keep the constant 3. Then I will differentiate s to the power 2. When I differentiate s to the power 2 by the power rule, it is 2 s to the power 2 minus 1, which is 1. So I have 2 times 3, which is 6. So I have 6x. Then plus I differentiate this constant. I know that anytime I differentiate a constant, it is 0. So that one will not count. So I have 3x squared plus 5 times 4x to the power 3 plus 2 minus s to the power 4 plus 2s minus 1 times 6s, all divided by the square of the denominator. Please, the expansion. In an exams, you will not see it like this. I will expand it. But here, the most important thing is for you to get the concept. Expand and simplify. Please, you did this one somewhere. I don't know if it is SHS or JHS, if it is core maths or elective maths, but I know you have done simplification before. It was a whole topic. So you don't do simplification here. So I treat concepts. I'll treat the concept, by the simplification, you have to do it. And in mathematics, any time you solve math, you have to simplify. So you may not get this, or you may not see this in an exams. Please, in an exams, you will not see this. Please. Are you okay?
Madam, come again.
Please, are you okay?
Madam, it's not
Come
in
again.
objective, so
With your last statement, that we may not see this.
I said that. No. I mean, if it's an objective question, you will not see this, because I will simplify further. I will simplify further.
Thank you.
But
please,
in the
Doc, this
notes,
one is
I've given you
objective.
this. I know that you know how to simplify. You know indices. You are combining indices and everything here. Please, because s to the power 2 plus s to the power 3, you know it is indices. So it's 2 plus 3. Me, I will not do that one here, because JHS, you teach this canary. So me, I will not teach you here. Thank you.
Madam, if you
Can I
do
continue?
that,
So please open your mind. So be a wide dream. Now, if I don't tell yourself that the course is difficult, so the thing will be, please, it is not difficult. The course is not difficult, and you are not only you are combining so many things. So please understand that you are adding every mathematics that you know.
Madam, a seminar
Thank you. Let's continue.
you are combining so many things.
My
You are
hand
combining
is
so
up.
many things.
And anytime you learn
Seminar,
mathematics, you don't
madam.
leave it to. When you learn mathematics, you go with it. When you learn simplification, you don't put simplification somewhere. You go with it. When you learn change of subjects, you don't learn at the GHS and leave it to. You go with, because when I give you a function and I ask you to find x, it is change of subject. You make s the subject. I will not tell you that make s the subject. I will ask you to find x. So you are looking for x. It means that if you have an expression, express it in terms of x, make s the subject. So everything that you learn, please, you cannot forget. Please. But we are building on what you know.
Yes,
so that's what we're
madam.
doing here. Please want to look at differentiation of trig function. Mention down because you had and it's not that difficult. Please,
Madam,
it's not
but it's
difficult.
like we have a chain rule, but it's like I didn't see it from the rules, or it's not part. Because back
You
I
have
said
what?
they taught
Chain
us
rule.
chain rule. Yes.
And we'll get the anchor in
Hey,
your to your boss actually can. We'll get there, okay.
Madam, please,
Chain
I
rule.
have a question.
It's sure about one watcher.
Okay,
You are putting
you
yourself into trouble.
ask your question.
From this one, go to Terry.
Hello, madam.
Yeah, Justina, I'm
Hello.
here.
Madam,
Yes,
please,
Justina.
the denominator, you didn't differentiate it, meaning we don't differentiate the denominator.
Hey, man, that my product.
So you go by the theory. It says that it is you just write the denominator there. So this is the theory. You write the denominator there, you differentiate the numerator, minus you write the numerator, you differentiate the denominator, all divided by the numerator squared. You don't differentiate it.
Okay, thank you.
You don't differentiate the numerator.
So that's what I've done here. So I write my denominator, I differentiate my numerator, minus I write my numerator, I differentiate my denominator, all divided by the denominator squared. So please get the concepts and then get the understanding. That's all that you need. So please, this is what you need. And you know what G of X is, what F of X is, and you'll be good to go. Now I want to look at differentiation of trig functions. You know trig functions, the sine, the cosine, the tan, and the rest. So we'll begin with the basic two the trig functions. We'll look at the sine and then the cosine function. He says that for any real number x, differential of sine x is equal to cos x, and differential of cos s is equal to negative sine x. Please keep this one in mind. Anytime you differentiate sine with respect to x, sine x with respect to s will give you cos s. Anytime you differentiate cos s with respect to x will give you negative sine x. Please, you will carry this one till thy kingdom come. Let's continue. Example, let f of x be equal to x sine x minus cos x. And here I apply difference, so sum of difference rule, then I'll differentiate my cos x. So let's see how to differentiate that. I didn't hear you, but my emergency I didn't hear. My father basa. I did was so relaxing. You have to relax. You drink some juice. You drink some juice and try to get the concepts.
It's not difficult at all. I can see that.
Juice, buy the juice, sit down, and then just try to get the concepts. I didn't hear thing. One more be that thou said, Namati Dawson. Now, there, I didn't hear my idea.
Madam, and they will tell their student that math the fool.
San no muka students.
Madam, you butcher, you butcher.
But I fool, I didn't hear fool so. But the teacher say won't hear say no koda da say one year there. You should understand it.
Madam,
I was at the end of the
I'm careful, but time in any hole, time is short.
So I have f of x is equal to x sin x minus cos s, Martin. Okay, so I'm telling you that this is a product of functions. Can you see that this is a product? Can you see it as a product?
Yes.
Yes,
Madam.
yes, please.
Yes,
madam.
Madam, your screen is it is blank. I can't see anything on the screen.
Okay, so try and solve this one for me. I'm giving you 3 minutes to solve this. When I come back, one lady will give me her solution, and then one guy will also give me, a lady will give me her solution, and then a guy will give me his.
Dina will give us the solution.
3 minutes or 3 minutes. Solve this.
Madam, please, there's a question. Oh, it's on the screen.
Please, the question
My
is on
screen
the screen. It's on
my
the
screen is blank. I can't see anything on
Okay,
the
so
screen.
it is x sine x times sine x minus cos x. Temperature.
Club beer. I know I messed up. Let's use the overflows of x minus cos x will be x d dx x dx sin x minus b dx.
Hello, madam, please, we are done.
This my madam is going to eat fufu.
Okay.
Guys, please, the class is being recorded though. Let's be mindful of what we are saying.
So Christian. Christian, no, not Christian, but Anof will say Akono.
Yes, madam.
Akono. So what did you get?
Yes, so the function was x sine x minus cos x.
Okay.
But the first function x sine x is a product of x and then sine x. So I used the product rule.
Okay.
When you use the product rule, I maintained x and then I differentiated sine x to get cos
So
x.
what do you get? What do you get when you differentiate sine x?
You get cos x.
Okay, so let me just write x d dx of sine x. So let me write it like that. Then what again?
Then plus. Then
Plus
I
or
maintain
minus?
sine. plus I maintain sine x and then I differentiated x.
Okay, plus. Okay, then you maintain sine x
and then I differentiated x to get 1.
differentiated x ddx of x.
Yes.
Okay.
Then minus. Then I'm differentiating cos x.
Differential of cos x. Okay, so let's continue. So I have x. Differential of sine x is
cos x.
Cos x.
Plus.
Then plus. I have sine x. Then differential of x dx is.
Differential of x is 1.
It's 1. So sine x.
Yes.
Then minus. What do I get when I differentiate cos x?
You get minus sine x.
So
that can be in the bracket.
Minus sine x.
Yes, please.
So this will give me x cos x
plus sine x
plus
another sine x.
So this will
we are
give
getting x cos x plus 2 sine x.
Okay, thank you. Anyone with a different solution? Anyone with a different solution?
No, madam.
Did you get the same thing?
Yes, please.
Okay. Thank you very much. So you are supposed to get this.
Yes, I got the same thing.
Okay, thank you. So let me see if I also got the same thing. So I'm differentiating x sine x minus d dx of cos x. And as I said, we are using product rule. So I'll keep x, I'll differentiate sine x plus, I'll keep sine x, then I'll differentiate x minus the differential of cos x. Then this is x. When I differentiate sine x, I get cos x plus sine x. When I differentiate x with respect to x, I'll get 1. So this is sine x. When I differentiate cos x, I'm going to get negative sine x. So negative will give me positive sine x. So this is x cos x plus 2 sine x. Let's see this one. Let's differentiate this. Okay, so I want to differentiate f squared plus 1. So I have f of s is equal to f squared plus 1 over. It's equal to 1. Okay, so this 2 over, please, the denominator is what? 1 plus sine x. So please, let's differentiate this. So what do we use to differentiate this?
Quotient rule.
It's a measure of yes, quotient rule and sum rule.
Okay, so let's quote the quotient rule. So f prime will be, what should I write first?
1 plus sine x. You write the
1 plus
denominator.
sine x.
X. dy dx.
D dx. It's not dy. Yeah, y is not here. So d dx of
x squared plus 2.
x squared plus 2.
Minus x squared plus 2.
x squared plus 2.
D dx.
D dx.
1 plus sine x.
1 plus sine x.
All over. 1 plus sine x all squared.
1 plus sine x squared. Yeah, no. So it is 1 plus sine x. Let's differentiate x squared plus 2. What do I get when I differentiate x squared plus 2?
2x.
2x. 2x.
I'll get 2x minus, then I have x squared plus 2. What do I get when I differentiate 1 plus sine x?
Cos x.
So this will give me cos x. Then all divided by 1 plus sine
1 plus sine x all squared.
Then you should be able to simplify this.
Yeah.
So the rest you should be able to do it. So that's what you have to do. That's what you need. Okay, so this is what you have to do. It is 1 plus sine x, 2x minus x squared plus 2 into cos x, all divided by 1 plus sine x all squared. Then you can simplify. So you simplify, you're going to get 2x plus 2x sine x minus x squared cos x minus 2 cos x, all divided by that. You can simplify further. If it cannot be simplified further, then maybe you leave it there. Okay. So that is that. Then we want to continue with the theory. It says that for each real number x, for each, yes, actually, yeah, that was why. What do you mean? For each real number s, for which the functions are defined, the differential of tan x is sec squared x. So anytime you differentiate tan x, you're supposed to get sec squared x. Differential of sec x with respect to s is sec x tan x. Differential of cot s with respect to x is negative cosec x. Differential of sec cosec x, it is cot, and cosec x is negative to cosec, so cosec x is cot x. So example, want to find f prime if f of s is equal to tan x over 1 plus 2 sec x. So this one we have to use quotient rule. So d dx of the function. Quotient rule, I'll keep 1 plus 2 sec s, then I'll differentiate tan x minus tan x times the differential of 1 plus 2 sec x, or divided by 1 plus 2 sec x all squared. Where am I? Okay. So I have 1 plus 2 sec x. Differential of tan x is sec squared x. So I have sec squared x minus, I have tan x. Then I come here, differential of 1 is 0. So I'll differentiate this. This will give me 2 differential of sec x. And differential of sec s is sec x tan x. So I have 2 sec x tan x, all divided by 1 plus 2 sec x squared. So we can simplify if it's possible to do that. Is there a hand up? There's no hand up. So that is any question. I hope you get this one. Yes, C vibes. And Joshua.
Madam, please, there's a question. With the identities, I don't know, the trig identities or things. Will we get some formula book for that, or we have
Please
to get
no.
this one in the head?
Please no. You will not get any formula book.
In the head. Oh, okay. No problem.
Madam, please, can
please,
you do
Madam,
cancellation?
Yeah, you can simplify and you can simplify. Joshua Lampton.
Madam, I wanted to ask the last part. You get, when you simplify when you differentiated the function, you get 1 plus 2 sec x multiplying sec square x minus tan x 2 sec x tan x, all divided by 1 plus 2 sec x all squared. Is that the answer, or you can simplify it further?
You can say, if it's possible to simplify, you can simplify it further.
Okay, so this is the answer, right?
You can simplify it. Sec squared can multiply this, then you have sec squared x plus twice sec cube x, then minus 2 sec x tan squared x, all divided by 1 plus that. So you can simplify it.
Okay. Thank you very much.
You're welcome.
Hello, madam.
Hello.
Hello, madam. So here,
Hello.
if you want to simplify, looking at the denominator, it is all square. Can you use one of them to cancel the 1 plus 2 sec x
Please,
so that it remain
1 plus 2 sec x is multiplying only sec squared x. It is not multiplying this one. Unless you...
I am talking about the denominator.
And then, I mean, the denominator is dividing everything. But the 1 plus 2 sec x
So
is multiplying only one term. It's multiplying this one. It is not multiplying this one. So you cannot divide. You cannot cancel out. Please open your eyes and look at it well. Okay.
Madam, can you break it into two?
Can I what?
Can you break that one into two, whereby dividing this one and the other one too, so it can cancel?
You can break it into two. Yeah, it's possible. Okay, we want to find the derivative of f of x is equal to cot s. So this one, we know the derivative, but I want to prove it, that when you differentiate cot s, you're going to get. So this one, we have f prime. So we know that cot is the same as 1 over tan x, right? So I want to differentiate 1 over tan x. And I know that tan is sine over cos. So since it is 1 over tan x, when you reciprocate it, you're going to get s over sine x. Okay. So this one, I will use the quotient rule. So quotient rule, I have sine x, then I will differentiate cos s minus cos s, then I'll differentiate sine x. Then this will give me sine x. Differential of cos s is negative sine x. So I have negative sine squared x minus, this will give me sine x times differential of sine, this cos s times differential of sine s is cos. So this will give me cos squared x. So I have 1 sine squared x minus cos squared x, negative, divided by sine squared x. Okay. Then you have to use, so I'm coming. So sine squared x, so negative sine squared x minus cos squared x is the same as negative outside sine squared x plus cos squared x. Then we have one identity of this. I'll write 1. So I have negative 1. So the top one, the top 1 will be minus 1 divided. They're using some even trig identities too. So if you've not done trig before, you have to read about trig 2, because we are using trig identities. There are some things that you have to use other things from somewhere. Okay, so we have negative 1 over sine squared x. This is the same as 1 over sine x times 1 over sine x. And 1 over sine x is cosec. It's a cosec. Yeah. 1 over sine s is cosec. This is cosec. So this is cosec. Please, you can write it cosec like this. Or you can just write cx. So this is what I have times cs c of x. And this will give me cosec squared of x. Negative, I have negative. So I have negative cosec squared x. So that's 1 over sec squared x, and it's the same as negative cosec squared x. I'm continuing. Please, I'm continuing.
You can
Okay,
go on.
madam.
Okay,
Madam,
madam.
fire on,
Then
fire on.
continue. Fire, fire, fire.
So the next thing, I want to look at chain rule. Okay, so I want to look at when you have composite functions. So you did composite function to somewhere. Okay. So if f is differentiable at x and f is differentiable at g of x, then I can find f of g of x. So composite function, that's a composite function. This function f depends on g, and the g also depends on x. So f of g of x is differentiable at x, and the derivative of f of g of x is given as f prime of g of x times g prime of x. Or this is d dx of 4. So this one, you did this one in elective math SHS. This is a composite function of x. Okay. So it says that an easy way to remember the chain rule is to suppose that u is equal to g of x and y is equal to f of u. Then your dy over dx is equal to dy over du times du over dx. So now we are changing this function. We are letting g of x be u. And I'll let my, so if g of x is u, then it means that I'll have f of u. Then I will let my f of u be y. So if I want to differentiate the y with respect to x, then it means that first I have to differentiate the y because this function depends on u. So I have to differentiate the y with respect to u times I differentiate my u with respect to x. So example, yeah, please, you can talk. So you have y is equal to s to the power 2 plus x all to the power minus 5. Okay. So to differentiate this, we want to use the chain rule. So I will let what I have in the brackets be my u. So I have u is equal to s to the power 2 plus x. Then I will differentiate this u. You can see that, okay, so I have yes, I'm coming on. Ishra, Martina, please call Ishra for me. So I have, so we are saying that if I have a function f that depends on g and also depends on x, then what I will do is I will let my g of x be equal to u. So it means that this function will be equal to f of u. Then I will let f of u be equal to y. So if it's like that, to find dy over dx, please look at the formula. The formula is dy over du times du over dx. So please look at the formula. So I have dy over dx is equal to dy over du times du over dx. let's put this one in a box. So for the example, I have the function y is equal to x squared plus x all to the power of -5. So what I will do is I will let what is in the bracket this be u. So I will let u be equal to x squared plus x. Okay. In the formula, I have to find du over dx. So my du over dx, it means I want to differentiate this function with respect to x. And what do I get when I differentiate this with respect to x?
2x plus 1.
So I'll get 2x plus 1 like this. So this means that now my y will be u to the power -5. So let's differentiate y with respect to u. What do I get when I differentiate this with respect to u?
-5u
-5 u to the power
-6.
-6. Okay. So the formula says that my dy over dx will be dy over du. So what do I get for dy over du? Dy over du is, what do I get for dy over du?
2x plus
-5
1.
u to the power -6.
-5 u to the power -6. Then times, so times the u over the x. And what do I get for the u over the x?
2x plus 1. 2x plus 1.
2x plus 1. So I will just replace my u by x to the power 2. So this is -5 into brackets x squared plus x times 2x plus 1. This is to the power -6. So this is the final answer I'm looking for. Okay, so let's continue.
Madam, can you use the shortcut to get the answer to?
What's the shortcut?
Like when they say y is equal to, like y is equal to the x squared plus x all power -5, no? Like you just come down and write the index.
Okay, so write it for me. What will you get?
So when you write the index, you have -5. So then you then differentiate the individual terms in the bracket. So when you
So give me.
differentiate the
Okay.
what? Okay.
Listen, I'm listening.
When you differentiate the x squared, you have 2s. And when you differentiate the x, you have 1. So it means that you, since the index is already down, you have -5 times the differentiation for the first term, that's 2x, times the other term, that's 1. Then you multiply by the term itself, that is in the function itself, and the function is x squared plus x power -5. Then you then subtract 1 from the exponent, and you multiply or you get the answer.
Thank you very much. Thank you very much. We will get there. You get the same thing, but we call that one general power rule. Hello.
Hello.
Sir. Go. Whether or you
from your network. Oh.
Fine. So
We can't hear you.
yeah. That
Hello, madam, please, we can't hear you.
Hey.
It's lectures over because I can see people leaving.
I think she's sorting out her data, her network. So let's wait a little.
Yes, it's 4 hours. So we can see.
Some of us will do the class.
Sundays are 3 hours, Saturdays 4 hours.
6 o'clock.
Then it will be 5 o'clock.
Court rep, please, when are we closing?
We have to cook for our children.
Court rep.
6 o'clock.
Let a dog now watch
Please,
me.
when she joins, she let us know. I'll try and call.
I do also interested.
Hey.
Colleagues, please. My mind is full right now. I can't contain another information. Please, if you don't compare with us, and then it's not easy at all. It's not easy.
Are you sure? Are you sure?
Oh, my mind is full. It can't contain information. Even it seems I'm even trying to.
So when are we closing? 6 o'clock.
Please, Doc will join us very soon. So let's.
6 o'clock.
Please, so stop the 6 o'clock so that it doesn't come true, please.
It's 4 hours. So maybe 6.
No visual. This course needed much time to study. Not this.
In fact, looking at the nature of this course, we need to get enough time to study.
Let me say, Mr. Gosi.
Sarek, God will help us. Sarek.
Yeah.
boys won't go
Justin,
watch
I
ball.
haven't
It be
called
like
madam.
Charlie, boys won't go watch ball. It be like you go close to o'clock. Boys won't go watch ball. We all go close to o'clock.
Please play this recording. Please play this recording.
Oh, is Madam not coming?
She'll join us soon.
Hey, are we done?
Nsem
Yeah, I think so.
We are
So
still
that
waiting for you.
if the course rep will talk to madam, so that tomorrow we continue with the other part, and we'll go and revise what we've learned today, and then we meet her tomorrow because it's not easy.
Charlie,
Charlie,
no
let
be
her
easy.
join us
Let's
soon. She
today
said she'll join us
because
soon. So
tomorrow,
let's
tomorrow,
It's a good
tomorrow we
idea.
have other things doing.
she said she'll join us soon. So please let's hold on.
So no, the time must be specific, oh, brothers and sisters. Sometimes the time somebody says to me from 4 o'clock for what? 4 o'clock a.m. for what? But when are we supposed to close?
Call this recording, please. Call this recording.
Yeah, please, we're supposed to start the meeting around 2 o'clock. I don't know where they change the time. And look at how we are suffering now.
We are confused to clear this block. Confused in pay. Answer. Call a spade a spade. Don't call it a house full. We are confused. Everything confused.
Mike, code is recorded. Please, Mike,
Please,
code
we
is
are,
recorded. If you have any issue, channel
please,
to your
you are not,
conscience. Please, code is recorded.
please, you are not confused.
Madam is in, oh, please. Madam is in.
Please, I'm here. Please, hello, please, I'm here.
Yeah, madam, you are welcome.
Welcome.
Hello.
Yes, madam.
Thank you.
Yes, our lovely madam. Lovely madam, you are welcome.
I can't hear. I can't hear anything. Whether I don't know whether it is my end.
We are all stuck.
Hello. Hello.
Yes, lovely madam.
Please, I'm back. I'm back. And I said that you are not confused. And the block, there's nothing wrong with the block. My data got finished, and I think that's a normal thing. So I had to buy a new data. So it's a normal thing. So there's nothing wrong. There's nothing wrong with the block or the course. Please. Let's just try, and then, because wherever you go, it's difficult. Depending on your mindset, you decide whether it's difficult or not. So please, let's concentrate. Let's try our best, and everything will be fine. Please, don't get tired. Just why do you say you can do it, please? So
Yes,
let's
please,
continue.
madam. Madam, please. So what time are we
It has
closing?
got nothing to do with it. I want to finish at least this unit, and if possible, maybe start another one, or at least finish this one. But the way you are behaving, I don't know. So please, you just take.
Madam,
It
you
looks
mean
like
you are completing the whole unit today?
oh no, week 5. This week 4. We are supposed to do 6 weeks, and this week 4. Next week I'm supposed to do week 5 and 4. So let me finish this week. This one here. Let me finish.
So, madam, please, what time are we closing?
And so,
Madam.
me and fast. Let me close it. So let's continue. Maybe a unit waste is here very soon.
Mijudi.
Okay, so find the YDX.
Yeah, calculus of calculus.
Find the YDX if y is equal to sine 5x. So as I said, you let your u be sine x, then it means that your y will be u to the power 5. So the formula is dy dx is equal to dy du times du dx. So I have to find the y du. My y is u to the power 5. So dy du will be 5. It will be 5u to the power 4. And my u is sine x. So the u dx will be cos x. So when I substitute, my dy du is 5u to the power 4, where my u is sine. So I have 5 sine to the power 4x, and my du dx is cos x. So this is the final answer. There's another one here. I want to find the y du, where y is tan into bracket 3x squared plus 1. So here I will let the angle be my u. So I have u to be 3x squared plus 1. Then my y will be tan u. du dx will be 6x, and dy du will be sec squared u. We know the differential of tan u is sec squared u, and I know that u is 3x squared plus 1, so you can just do the substitution. And your dy dx will be dy du times du dx. So my dy du is sec squared into bracket 3x squared plus 1, then times 6x. That is it. The alternative approach is what our brother asked, but we will get there later. So XO is here. So this is what he asked. We call it the general power rule. So the general power rule says that if I have a function So the general power rule says that if I have a function, f of x, then the f of x is to the power n. If f of x is differentiable, I want to differentiate this. So dx of f of x to the power n, the power rule is given by, so I'll drop my n, I'll keep the function, so I'll keep my f of x. Then I'll have n minus 1. Then after that, I will differentiate the function. So I'll have f prime of x. This is called the general power rule. So you dropped your n, you have the same function, f of x to the power n minus 1, then you differentiate the function. So example from what our brother asked, the first one he asked if we can solve this using the general power rule. Okay. So I have x to the y is equal to x squared plus x to the power minus 5. Okay. So to differentiate this, my y prime will be, so using this rule, I'll drop the minus 5. So I have minus 5 into brackets x squared plus x to the power. So I have minus 5 minus 1, which is minus 6. Then after that, I will differentiate this. So differential of x squared plus x is 2x plus 1. And you will see that when you compare it with the quotient rule, we had the same thing. Negative 5 x squared plus x to the power 6 times 2x plus 1. So that is the general power. So the same thing, if I have y is equal to sine 5x, I can use the general power rule to solve this. This is the same as sine x all to the power 5. To use the general power rule, I have my 5, so my y prime is, I have the 5, then I have sine into brackets 5 minus 1. 5 minus 1 is 4. Then times the differential of sine, which is cos x. So this is 5 sine 4x cos x. So that's all you get. So the ones that we can use the general power rule to solve, with the quotient rule to solve, we can also use the general power rule. Please, am I online?
Yes, madam.
Yes, please.
Yes, madam.
Am I?
Yes.
Is it okay?
You are live.
We are there.
Okay, so let's continue. So example, if I want to find y prime, oh no, so that is the general power rule. Okay, so on the general power rule, I have y is equal to this. Okay, so to differentiate this, please, anytime you differentiate a function, a trig function, after differentiation, you have to differentiate the angle too. So this one, for instance, after differentiating, I'm supposed to differentiate my x, but I know that when I differentiate x, I will get 1. So anytime you differentiate trig function, when you are done, you have to differentiate the angle too. So example is this.
We use this for the money.
Is it?
So I want to differentiate y is equal to cos cube of s squared plus 1. S squared plus 1. Okay, so this y can be seen as cos. The angle is s squared plus 1, then all to the power 3. So using the general power rule, I have y prime to be equal to, so I'll drop my 3, then I'll have cos s squared plus 1, then 3 minus 1 is 2, then I will differentiate this. I know that when I differentiate cos, I will get negative sign. So negative sign of the angle. But I said that anytime you differentiate trig function, you have to differentiate the angle too. So even though we are done with the general power rule, I have to differentiate the angle. So differential of the angle, which is s squared plus 1, will give me 2x. So this will give me negative 6x cos x. So the 2, I'll bring the 2 to the sign. That's how we write it. So cos squared x plus 1, then sine into s squared plus 1. This is what you get. So please, we are using the general power rule. Then I'm differentiating the angle too.
Madam.
Hello.
Madam, the second step,
Yes.
where you have cos cube bracket s squared plus 1, and the second expression is not clear to me. How you put them together?
I
And
said
you
that
put
cos
everything.
cube is the same as cos x plus 1 all to the power 3 is the same thing. The trig function, we don't write sine x square like this. We bring the x square here. So instead of this, we bring it here. But to simplify what we want to do, instead of this, to help you to understand it better, it's better you write it x like this, so that you can apply the rule. So if it is cos cube, maybe x, I will write it as cos x, then I'll bring the cube, so that when I differentiate, I will get 3 cos x squared. So I can bring the squared here. That's the best thing, is to write it like this, times the differential of cos, which is negative sine x. Then differential of sine of 1 or x is 1. So I have it like this. Are you okay?
This one is clear, but how you know the cube was only affecting cost? The cube was only affecting cost. By in that expression,
Was not
you put the
please. It is not only affecting cost. It's like, so this expression here is the same as writing cos s squared plus 1 times cos s squared plus 1, then multiply it again by cos s squared plus 1. But when it comes to trig, we write this expression like
I'm clear now.
cos cube x squared plus 1.
I'm clear now. Thank you.
Okay, you're welcome. Okay, so let's continue. So it is 3 cos squared, 3 cos squared x squared plus 1 implicit differentiation. Okay, implicit differentiation. We apply the implicit differentiation I've met so far can be expressed, can be described by expressing one variable explicitly be described in terms of another. For example, we have y is equal to this, or y equal to this, or in general, y is equal to f of x and y, such as x squared plus y squared is equal to 25, or sign into brackets x2 is equal to 4. Okay, so some of them we cannot define y in terms of the other, but they are expressed in another way. When it comes like that, fortunately, we don't need to solve an equation for y. So when it comes like that, we don't have to make y the subject, but we can differentiate by using what we call implicit differentiation. Y plus x is equal to 2. Okay, so that we can see product of two differentiable function, a constant times a differentiable function, to another differentiable function. So we differentiate both sides. We have differential of the left and a differential of the right. Okay, so let's look at how to differentiate the left. The left is
Doc, please, would the question
yes.
specify we are to use implicit differentiation, or how would you know that you are going to use implicit differentiation?
Please,
Doc, I was asking whether the question will tell you to use the
So
implicit
just when
differentiation
we
or.
read, it says that some of the functions, it's difficult to express x in terms of y. So okay, so sometimes it will tell you to use implicit differentiation, but sometimes when you see the question, you will know that it's only implicit differentiation that can help. But sometimes you can state, even this one I can make y the subject, but it will be a little bit difficult. So when you have a question like this, the best way to solve this is by implicit differentiation. Okay, so by implicit differentiation, I'm using product rule here. Then I'll differentiate this, I'll differentiate this. So product rule, I'll keep x, I will differentiate y plus, I'll keep y squared, I will differentiate x plus, so I'm done with the product rule. Then I'll come here, differential of this is I have x6, and differential of this is dy over dx. Then I'll differentiate this, so plus differential of x will give me 1. So I'm differentiating everything with respect to x. So this is x, d dx of y is written as dy over dx plus y squared. Then I have y squared d dx of x is giving me 1. So this is 1 plus this is 6 dy over dx, then plus 1 is equal to 0. So I want to find dy dx. So to find dy dx, I have 6 dy over dx plus, I have x dy over dx plus 6 dy over dx is equal to minus 1 minus y squared. So I have dy over dx in a bracket, x plus 6 is equal to minus 1 minus y squared. So my dy over dx is equal to minus 1 minus y squared divided by x plus 6. So that is it. Are you okay?
No, madam.
Hello. Hello.
Madam, please, can you go over again?
Hello, madam.
Hey, so
Madam, please,
okay,
can you
let
go
me
over
clean
again?
it. I think there's a mistake. I think there
Yeah, when you differentiated the y square.
is a mistake. Let me clear it. Oh. Yeah, when I differentiated the y square, I was supposed to use the general power rule. So let me clean it and then go over it again. Okay, so I want to differentiate xy squared plus 6y plus x is equal to 0. So I'm differentiating xy squared plus I'm differentiating 6y plus I'm differentiating this plus I'm differentiating 0. So here I use product rule. So to use the product rule, I'll keep this. So when I keep this, I'm going to get x, then differential of y squared plus I'll keep the y squared, then I will differentiate the x. Then plus I will keep the 6 out. Then I have the y over the x. Then plus the differential of this is 1. The differential of this is 0. Okay, so let's come here. When I differentiate, I have my x. When I so this is, I have y squared. And I know that when I differentiate this, I have to bring the 2. Then I have y 2 minus 1, which is 1, times the differential of my y, which is y prime. So this will give me x squared, x into 2, y to the power 1 times y prime times y prime, or divide, let me write divide this, times and plus, that's all give me 6 dy over dx is equal to minus 1. We want to make dy dx the subject. So making dy dx the subject, I have this one, dy dx into 2xy, so that's 2xy plus 6 is equal to minus 1 minus y squared. So my dy over dx will be squared divided by 2 xy differentiate this. I have to differentiate this one, then I differentiate this. So okay, so I want to differentiate cos xy plus sine x. Casa no do so. also is equal to 1. Sine. So this will give me negative sign of this angle, xy. But I have to differentiate this. So dx or xy plus the differential of this will give me cos x. And differential of this will give me 0. Okay. So I have negative sign xy. Then to differentiate this, I have to use product rule. So product rule, I'll keep x, I'll differentiate y, which will give me dy dx plus I'll keep y, then I'll differentiate x, which will give me 1 plus cos x is equal to 0. So you make dy dx the subjects from here. So your dy dx will be equal to, okay, so I'm going to get, when I expand, I'm going to get negative x sine xy dy dx minus y sine xy is equal to minus cos x. So I have minus cos x plus y sine xy. Then you divide through to get your dy dx. Okay. So your dy dx will be dy dx or y prime. So as I did, I had negative sine xy into y plus x y prime plus cos x equal to 0. Okay. So this causes to be by minus s sine xy. Please, when you simplify this, you are supposed to get that. Okay. So you have minus cos s plus y sine x. Then you divide through by this. So that's what you're supposed to get. Okay. Then we have differential of natural exponential functions. Okay. So the first rule says that when you differentiate e to the power x, we are supposed to get e to the power x. But when you differentiate e to the power g of x, you're supposed to get differential of g of x times e to the power g of x. So example, if y is equal to e to the power x squared, when I differentiate, I'm supposed to differentiate the power, which is 2x. When I differentiate 2x, I'll get 2x. When I differentiate x squared, I'll get 2x. Then times the function itself, e to the power x squared. So example, if y is equal to e, so there's supposed to be e or exponential ex sine 2x plus e cos 2x. We want to find y prime. Okay, so we can see this as a product of two differentiable functions. Okay, so this means that I have to use product through here. So I'll keep e to the power x, then I will differentiate this, or I can, yeah. So I keep, okay, so let me just write it on the board. People are eating it. So I want to differentiate e to the power x to x. So y is equal to e to the power x sine. So I'll keep e to the power x, then I'll differentiate sine x. When I differentiate sine x, I'll first differentiate the sine, which will give me cos x. I'll maintain my angle, then I'll differentiate my angle, which will give me 2. Then plus the power x is e to the power x. So this e to the power x. So I'm done with this using product rule. Plus, I'll come here. I know that when I differentiate this function, it will be differential of the power. So I have to differentiate the power cos x, which will give me minus sine x. I'll differentiate sine 2x, which is cos 2x times 2, plus I'll keep the sine 2x, then I'll differentiate e to the power x. Differential of e to the power x is e to the power x. Then plus, I have to differentiate the power, which is minus sine x, then plus times the function itself. So that's what I get when I differentiate this.
Hello, madam. Please,
Okay,
I
so
think
that is it.
where we are now, we are
Sine
at a very
2x
critical area, but
plus
the network is
e
not favoring us.
to the power s plus 2s sine x.
Hello, madam. Hello, madam.
Good. Hello.
Hello, madam. Hello,
Hello,
madam.
Oliver.
Madam, please, I'm saying that I think we are at a very critical area, but the network is breaking.
Let me see if I can make something about it. Is it okay now? Is it okay now?
Madam, please, as for me, I didn't get it all because
Hello, is it okay now?
the line was breaking
Yeah, the
since
line
we
was breaking.
started from there.
We didn't get it unless you
Yes,
go back
madam.
again for us.
Hello, can you hear me?
Yes.
Yes.
Hello, Richard.
Hello.
Hello, Richard.
I can hear you.
Can you hear me? Okay, so let's try and end at 5.
Okay.
Okay.
No, let's end at
Okay, so
6.
let's continue. We want to look at differential of natural log.
Okay.
No, it will end as 5. When we differentiate ln x, you're supposed to get 1 over x. So example, if my y is ln sine of x, I know that my g of x is sine x. So when I differentiate this, I'm supposed to get differential of sine x divided by sine x. So differential of sine s is cos s. So this will give me cos s over sine s, which is cot s. This is a combination of so many things. So I want to differentiate y prime, y, if I have my y is sine into brackets s squared plus 1 ln x plus ln 4 s cubed plus 3. So the top one is the product of two functions. So I have to use product rule. So I maintain sine s squared plus 1, I'll maintain it here. Then I will differentiate ln x. And we just saw that differential of ln x is 1 over x. Plus the next one, I will maintain ln x. So I maintain ln x. Then I differentiate sine s squared plus 1. When I differentiate sine, I know that it's going to be cos. I will maintain my angle with s squared plus 1, which will give me 2. The ln g of x is differential of g of x. So I differentiate the g of x, which is 4x cubed plus 3. When I differentiate 4x cubed plus 3 is 12x squared. This will give me 0. So I have 12x squared all divided by my g of x, which is 4x cubed plus 3. So that's what I have. Then we also have differential of general exponential y is equal to a to the power x. Okay. Anytime you have a function like this with something up there, what you have to do is you introduce ln to bring the power down. So I have so you have y is equal to, okay, a to the power x. Anytime you have something like this, what you have to do is first you introduce natural log. Hello.
Madam, it's like
Hello,
where
please,
we
I'm
are,
here.
no, they are new concept. Where we are is a new concept, but it's like you are going too fast.
But if I
let her finish. Then we'll go over if you have any question.
Okay, so if you have any question, you can ask. So if you have something like this, you introduce lane. So I'll take lane on both sides. And one law of lane says that if I have lane a to the power x is the same as bringing the lane x down, then I have lane a. So I have lane y is equal to x lane a. I've seen this phase before, or please see, you can set
like that of
comment.
organism.
Okay. So I want to differentiate this. The lane says that when I differentiate lane function, it is differential of the function. So I have y prime divided by y is equal to, then I differentiate this. This is a constant. Lane a is a constant. So I'll bring my lane a here. Then I'll differentiate my x. When I differentiate x, you know I'll get 1. So I make y prime the subject. My y prime will be y lane a. And remember, y is a to the power x. So my y prime will be a to the power x lane a. That's what I get when I differentiate this. So when you differentiate y is equal to a to the power x, you are supposed to get lane a to the power x. It's good. Go and call daddy. Okay, he said he's coming in. Okay, y is equal to 4x. So we have y is equal to 4 to the power x. So I'll introduce lane. I have lane y is equal to lane 4x. So lane y is equal to x lane 4. So this is y prime over y is equal to x. Master, so we make it okay. So we are oh sorry, I differentiated only part. I have to differentiate this one. Sorry. So when I differentiate this is a constant. So I have lane 4. Then when I differentiate x, this is 1. Okay. So my y prime will be y lane 4. And y prime is equal to, my y is 4 to the power x lane 4. So that is it. So that's what you get, lane 4 4x. So if I have a to the power g of x, so going through the same procedure, but I have to differentiate my g of x too. So this will be g prime of x ln a times the function. Okay, so I have ln a times g a to the power g of x times g prime. So that is it. So I have this function. So I have y is equal to 6 sine x. So thus I have to introduce ln on both sides and then try to differentiate. But you can, if you can remember this, that it is ln 6, then the function 6 to the power sine x times the differential of sine x, it's fine if you can remember this. But if you cannot remember, then you have to introduce ln on both sides and take your time to differentiate. You want to find y prime if y is equal to x to the power 5 plus 1 to the power 10 plus 10 to the power s squared plus 1. We know this one, you have to use the general power rule. So this is 10 s squared plus 1 to the power 9 times the differential of 2x squared, which is 2x, plus, then this one looks like a to the power something. So this is ln 10. Then you maintain the function 10 to the power s squared plus 1. Then you differentiate to the power, which is 2x. Then you can take your time and simplify. So the root 3 is the differential of log function. So if you have y is equal to log x base a, from SHS, we know that this is the same as a to the power y is equal to x. Then you can introduce ln on both sides. So I take ln on both sides. Then this y will come down so that I have y ln a is equal to ln x. Then I make y the subject. I'm going to get y is equal to ln x over ln a. Then I can differentiate. When I differentiate dy dx, this will give me 1 over x. So I have 1 over x. Then I will maintain my ln x. So example is this. I have y is equal to log x base a. When I differentiate, this will be, y prime will be 1 over ln 4 times x. Then the root 4, if I have y is equal to log g of x base a, then differential will be, okay, so it is 1 over g of x ln a times the differential of my g of x. That is it.
You need a book, formula book.
Formula book for the way. So let me end here. We'll solve this last one. And then we'll end.
Madam, we need the Yehusu.
Madam,
it's so difficult. Formula
it's not difficult.
It's not difficult. But the formula and then the identity, they are too much. We need to get some but could be so a advanced calculus. I'm saying those. Okay,
let's end here. We'll look at log of differential equation next time. So if you are not able to finish, next week, then you have to look for another time and meet. Please. Okay. I've just
okay, madam.
Okay. And then also next week I'll be traveling. So if you are making her,
we will go with you.
Oh no, I'm going to Accra. I'm going to Accra, but maybe a time number so not me will road the fly make off. It's also so
Madam, we'll come and meet. Those of
schedule
us
the
in
time.
Accra will come and meet.
I hear.
Those of us
I
in
hear.
Accra will come and meet you. Those of us in
I
Accra
hear.
will come and meet you.
Madam,
I hear.
save journey in advance.
Okay. Into next week, we'll discuss the best time for us.
Doc, if you are testing the questions, please, unit 1 and 2, right? Don't go far. Now, yeah. Some of us, we have 4 children. It's not easy.
Make an innovation. So we'll end here and then continue next time. So please, let me
Dina,
end.
won't you talk?
We'll continue next time.
Dina, talk.
I wish you all the
Group
best.
leader.
Yeah.
Thank you, madam.
Madam, please, the slide.
Thank you.
Jackson, you have to
Madam,
change
thank
your
you.
name.
Madam, the slides.
Madam, question. Hello, madam, please, question. Doctor, please. Please.
Madam child is crying. Oh.
Madam Ko.
Oh, baby, don't cry. Madam, go. Oh, we are dead, though. Charlie, for them, blood to be pressure. Oh, but what how la day ago?
Recording.
And then I started with me who's who.
Charlie.
You know, I'm the
Charlie,
Shada. What's the concept? You know, where's your SSS?
Charlie, SS no be you. SS Kakros be different. That one is introduction to Kakros. This one is Kakros into Kakros.
Now,
for
the hammer cry and chronic what your mother know. I'm serious. Above when I'm my brother. Oh. Fuck at them. We go kill at them. We go fuck at them. We didn't know Munima. Me have home baby the visa.
You go fuck at them. You go do them this. Then we are suffering for them.
Oh,
They
this
man, they suffer. First off,
the court is loaded too much. All
yeah,
these 3 weeks for 1 month.
Teacher for you. Teacher for you.
All this 1 month. the time is too short.
Charlie, the time is too limited. But the things are too many.
Those that are doing their PhD, would they even
It
do
shall
3
be
weeks
well.
to do this?
God grace.
Would they be able?
It shall be well.
Even the lectures that they are teaching us, if
It
you
shall be
say
well.
they
It's madam here around, please.
many. It's too many. The time should have been extended a little bit far. Let's say 2 months in Korea.
We must find right antidote for this course of time.
This one, there are no right
Please,
antidote.
is madam still around?
It's a matter of understanding.
Madam has left.
Oh, okay.
Then madam supposed to give us past questions to go through. None of you asked such.
That is why
maybe she will do that
when
for
we
us.
get past questions, then we can be solving and just
Questions alongside with the note, but this one there, because you know the nature of the question, then you know how to you structure yourself. Because this at the beginning, they give us the course after they give you past questions, solve past questions, question answer. There you go your way.
We don't sit at home and do it too. We should have do it sandwich. That one could have helped us.
Now for the calculus, 3 years require no see calculus stop. They want use 2 weeks to learn calculus to go and write and
Yeah, I
pass.
use 4 years in Korea, no see 4 years. I go 4 years.
4 years require no see calculus stop. You calculus 1, you know see top. We don't come do calculus 2, then calculus 3. You are dead finish.
In Korea, how they do this, I just they look am.
Charlie brothers, if anybody have any antidote, if oppose give me a call for this time. The things not they go well. All the courses
You know they go well on your side. We too for our side, no they go well.
I mean the way you put Yamuku, as if say you the things they go well give you people.
Yeah, who talks the things they go well give it.
Confusion.
When you ask too many questions, you say yourself.
Hey.
You ask too many questions, then the rest will be sometimes they are trying to be angry.
Annoying them what?
Yeah.
No. Charlie, if you don't understand, say that you don't understand. Don't you then go outside gentility home cry. You don't want that too.
Some of us at SHS, we didn't get the opportunity to learn it because of those who taught us. You see,
Oh,
Even
okay.
calculus, calculus. One of the topic that I dislike at the teachers.
Charlie, my brother be
Because
you.
the teacher
In my
himself
life,
didn't teach us into details.
I haven't even answered any calculus question in my life. I see I go jump over. I no
The
go
same
tempt that.
thing to me, the same thing, calculus question, having answer one.
Calculus. I haven't answered calculus in my life. Any I see the question, the calculus about calculus, I must suspend that question. Finish. No, no, no. I will not even attempt to answer the question.
When you
So
go and solve the calculus
I'm
problem,
pleading to madam that if we bring less only one calculus, the rest in there we can face it.
all calculus, eh?
Only one calculus, so that the calculus people will do the calculus, then we will do the other things for them.
Yeah, you should bring that Angus, and we will do some for top.
That one there we feel crack this one calculus in there. The YDS need be my enemy. I know they like that thing at all.
Even this when go to the SHA to teach, you must have to go to YouTube, do research before you teach proper. If not that, you just be looking at it. You'll be teaching, the children will be laughing.
Now you secondary school calculus one quite no sit up. You don't want to come do calculus two for here. Calculus one you know sit up. Calculus two you know sit up. They want come do advanced calculus. You are dead finished.
Advanced. This one advanced. You get the name. Advanced.
You are dead finished. Advanced calculus. You are dead finished. Calculus
Oh.
one you know sit up.
You know,
Calculus two you know
problem is
sit
that
up.
the time is too short. You take this one.
Abstract calculus. You
Even
jump to
the courses in crime, I'm confused with the course titles.
Charlie.
Sometimes the teacher don't even know the course they are teaching. Whether
they
it's
bombard
algebra and calculus, whether it's advanced calculus, they look alike.
My blood Michael no be see no be me alone we say I dey suffer. Michael we dey suffer. We brothers too dey enjoy when they do the minors.
Oh.
Charlie blood it shall be where we go pass through, don't worry.
I hear. Amen.
If we bring exams today now we go write for them and pass.
Amen. Amen to that.
We keep hope, eh?
Okay.
To four.